We made it! Woo! This is the last video ever! 4-5, power and efficiency. Let's get it over with. Alright, here we go. And there, efficiency. Again, efficiency is kind of like a ratio, but it is always answered as a percentage. So the difference is efficiency is actual mechanical advantage divided by ideal mechanical advantage times 100 will give us a fancy-dancy percentage, and all will be well with the world. The more efficient you are as a machine, the closer you are to ideal mechanical advantage, which is what we really, really want. Okay? So your AMA should be as close to IMA as possible. Let's dive closer. Sample problem. Now I told you that IMA is equal in this case, because this is an inclined plane, that it is the length of the effort, that's that guy, divided by the length of the resistance, which in this case is this guy. So that is 9 divided by 1.2, and that is, oh crud, I don't have my calculator. Hold on, wait, it's here. There it is. Okay. I was scared for a second. 9 divided by 1.2 equals 7.5. Wow. 7.5. And the actual mechanical advantage is the weight of the object, otherwise known as the resisting force, otherwise known as, lots of things. So that's the weight. That's force of gravity. And that's also just happens to be the resistance in this case. So AMA is the resisting force, that is 4,933, divided by the force it takes to pull this booger up the hill, and that would be this guy, so that's 730 N. So 4,933 divided by 730 equals 6.76. All right, now, as we've said, efficiency, EFF, equals AMA, actual mechanical advantage, divided by IMA, ideal mechanical advantage, times 100 equals a fancy-dancy percentage. So 6.76 divided by 7.5 equals times 100 equals 90.1% efficient. And let me tell you something, 90% efficiency is a really darn good efficiency. So happy day for that inclined plane. Okay, we've talked about in the very beginning of this, 4-1, that work is the force of motion. Motion force, the force of movement, the force that it takes to move an object. Not under any circumstances is it net force. No net force. Net force is bad when we talk about work. It's just the force in the moving direction, multiplied times this d, this little d, which means distance. And it's measured in joules. Okay? And joules is also the energy, or the unit for energy. And you know why? Because work equals energy. So both of these guys have a unit of joules, which means, remember I said that this we'd come back to when we were talking about it in 4-1, that power of a machine is measured in watts, okay? And in our first unit, electricity, energy equals power times time, otherwise known as power equals energy divided by time. And remember when I said that energy equals W, so it should be no shock to you when you find out that when we talk about mechanical energy, power equals work divided by time. What? It's like stuff is connected all the time. So let's look what we left. Really? Okay, that I can't. No, bad. No. A UF linebacker, prior to committing some form of felony, which will ruin his NFL career, is training for the next football season and can push a small car with a 30 N force for a time of 8 seconds. If the car is pushed 10 meters, what is the linebacker's power? So we want power, and we have time, and we have distance, and I have force. Now, at my disposal, I have this formula, work equals Fm times d, and I have this formula. I want power. This is the guy I want. I don't have work, so I'm kind of up the creek here without a paddle until I use this as my paddle. Work equals force, in this case, is 30 times distance, which is 10, which gives me a work of 300 joules. Wow. Power equals work, which is 300, divided by time, which is 8. And that comes out to another number, slightly smaller, meaning 37.5 watts. If you want to do it that way. Otherwise, if you don't want to spell it out, you can just do it as a W. That is the power of that particular linebacker. Cool. And then we learned about a geek, because what would a unit be without one dead scientist guy? Closest thing you need to know, or the only thing you need to know, is Watt, and the fact that he did a lot of work with this thing called the steam engine. Watt, steam engine, learn it, love it, and that's committed to memory. And that's it, ladies and gentlemen, boys and girls. That is me in a nutshell on these videos that you love so much. I'll miss it, maybe. I'll see you in class.